Hi there, I'm Amatov, and I'm going to be showing you how I made a face recognition AI. So first, let's download like 10 images of LeBron James and Roger Federer. So, one, save image as, image 3, save image as, image 4, save image as image 5. Okay, and here save image as, here image 1, image 2, image 3, image 4, and image 5. So now we can get to work. So the first script we're going to run is this image resizing.py. So basically what this is going to do is resize all of these images to I think it's like 160 by 160 pixels and make them all grayscale. This is just so that our program has an easier time going through all of them and it doesn't slow down a ton. So test here. So now if we go there, here, xdg open image1.jpg. Here, so you can see the aspect ratio's been messed around with a little. Image 2, you see they're all like kind of square. Image 3, yeah. So next we can run here face feature extraction. So this is where pretty much all of the big work will be happening, and we actually have to edit this here, face feature extraction.py, and we have to load the images. So we have our test photos over here, but let's actually let's make these our data, and then we're going to make another directory for test images. So here, Roger Federer, let's get one of him. So here, documents, there. So Roger1.jpg. Let's take another one of Roger, just for good measure. Here, let's take another one of LeBron 1, and then let's have here Katy Perry, save image perry.jpg, and golden retriever. Here, this will be our test. Here, goldie.jpg. So now we can edit that script again here. So this is going to be Roger, and this is going to be LeBron, and the test folder is test. So now let's run this script and see. Hopefully we won't get any errors here. Okay, so we have to install DeepFace. DeepFace is a Python module that we're gonna use. Basically, it's for interacting with a bunch of face recognition modules. So we're going to use this to interact with FaceSnap, for example. Basically, here, while that's plucking away, let me explain a bit about how this is actually going to work. So first, we already resized the images. Basically, that's just for ensuring consistency. And then next, you take embeddings from the images. So basically, what that means is, like, say I have this water bottle right here. I can say it's yay tall and it's blue. Those are embeddings of a water bottle. I have here these wires here, so I can take two wires and say one of them's orange, one of them's brown, but they're both the same length and they have the same type of head. So basically, embeddings are characteristics of an object. For faces, we're going to say how big is the nose, how big is the ears, what color are the eyes, stuff like that. So let's run this script again. Here. Okay. Here. So pip install tf keras. So after we get the embeddings, we're going to So over here we can see it found a match for Roger. Funnily enough, it found a match for the Golden Retriever, no match for Katy Perry, and no match for either of the Roger Federer images. For Roger 1 or LeBron 1. So you can see here it's not perfect. It probably had something to do. You can see here we had small data sets. So basically, next time what you'd want to do is have more images, because the more images it has, the more it can train. So after we take the embeddings from the image, what it does is it finds the cosine similarity of the images. So what's another example? Here, these two pencils. So two embeddings I can have would be the length, let's say that's, 15 centimeters and 20 centimeters, and the color. This is green, this is yellow. So basically, we store these embeddings as here 20 here. So in RGB, yellow would be 200 red, and green would be 0 red. So 15 and 150. So basically, in order to take the cosine similarity, you graph this. So 20, 200, here 20x and 200y. That's going to get us there. 20 and 200. And then we're going to have something like that there. 15, 150. So basically, what you do then is you take the cosine of each by drawing a line from the origin to that point, and then you see how close is the angle between these two lines. So basically, the closer the closer the angle is between those two lines, the more similar they are to each other. So basically, in this case, we have two embeddings, length and color, but for the faces, we have something like 128 embeddings. So that allows us to get really just to get a lot of information about the face. So I hope that was informative, and thanks for watching.